Hello everyone, we hope that you are all doing well in this particular time. First of all, we want to thank you for taking the time and listen to have a brief video. We had the opportunity to do a research about radiation in the laboratory landmark relativistic effects. I am Brenda and I will start by explaining the part on the radiation, then Adrien Boyenval will continue. And for the second part about relativistic effects, it's Khalil and Adrien Renaud who will explain to you. So to start, do you know what radiation is? We will quickly explain to you. So a radiation is a transfer of energy in the form of waves or particles which can occur through electromagnetics, radiation or decay. So therefore the transfer can take place in a vacuum. The characteristic example of a radiation is like the sun in space. In physics, the term radiation refers to the process of emitting or transmitting energy in the form of particles or electromagnetic waves. It includes electromagnetic radiation such as radio, infrared, light, X-rays, or even gamma rays, as well as a particle radiation. So the term radiation also designates the energy emitted and propagated, which is also called radiant energy. We also speak of light radiation and caloric radiation.
Okay, so now we're going to continue to talk about radiation, but this time it's going to be a little bit more specific, as we're going to talk about synchrotrons radiation, as the synchrotron is the system that we are looking at. So let's have a little look at what happens in it.
Synchrotrons radiation, also called curvature radiation, is an electromagnetic radiation issued by a charged particle which moves in a magnetic field, and its trajectory is deviated by this same magnetic field. The radiation is issued in particular from electrons moving around in a storage ring. Because those particles regularly change both the trajectory and the speed, they issue energy under the form of proton, which correspond to the acceleration they undergo.
So with that being said, we can conclude now that synchrotrons radiation is really stable in comparison to classic sources. It's also polarized, which means that it's fully dependent on the direction, and also it allows us to work in phases coherence.
I want to start by thanking my friends for their part on radiation, and we can move on to the second part of our subject, which is the relativistic effect. In physics, the qualifier of relativist applied to an object means that this object is animated at a non-negligible speed compared to the speed of light. Otherwise, we speak of a non-relativistic object. This vocabulary mainly distinguishes the theory that should be used to describe this object in question. For classical mechanics, it suffices to study non-relativistic object, while relativistic object must be studied within the framework of special relativity in general. These two theories are reduced to classical mechanics in the situation where the speeds intervening in the studied problem are sufficiently low, and there we can talk about Lorentz transformations.
Presentation of my colleagues on relativistic effect in physics. We will talk about those in chemistry. Relativistic quantum chemistry integrates results from quantum mechanics to account for the properties of chemical elements on the structure of the simple bodies, especially for the heaviest element of the periodic table. A well-known example relates to the color of gold, which is not a silver colored like most other metals due to a relativistic effect. Relativistic effect in chemistry can be considered as disturbances or small correction to the non-relativistic theory of chemistry, developed from the solution of the Schrödinger equation. These corrections affect the electron differently depending on their speed in relation to the speed of light. Relativistic effects are more important for heavy elements because it is only in these elements that electrons reach relativistic speeds.
Last of all, I I want to thank you for your time. I hope that you are taking care of yourself, especially in these difficult times. Bye bye.